Hello everyone, welcome to this lecture. In the previous lecture, I have talked about the functional completeness of multiplexers. In this lecture, I am going to demonstrate, in case a Boolean function is given, how we can implement that Boolean function using multiplexers. So let's see. Before going for the construction of or implementation of any Boolean function, just recall the output Boolean function of 2 cross 1, 4 cross 1 and 8 cross 1 multiplexers. So let's say there's a 2 cross 1 multiplexer, there'll be one select line. So if I write the Boolean expression or output y for 2 cross 1 multiplexer, there'll be one select line. This is output, let's say y, and this is input I0 and I1, right? So this y will give us, if this is S or S0, it will give us S0 bar I0 plus S0 I1, right? In case we consider 4 cross 1 MUX, in that case there will be 4 input lines, 2 select lines and 1 output y. So let's say it is S0 and it is S1, and these are like I0, I1, I2 and I3, right? So this expression we will get like S1 bar, S0 bar, I1, I0, or S1 bar, S0, I1 plus S1, S0 complement I2 plus S1, S0, I3. Similarly, we can write for further 8 cross 1 or 16 cross 1 MUX also, right? So please do remember this, because once a Boolean function is given, in order to convert the Boolean function into a circuit, we need to compare these functions with the given Boolean function. Okay, so let's take few example. Let's say a very easy Boolean function is given, so I want to realize, let's say you take XOR. So I want to realize XOR with the help of MUX. So the Boolean expression of XOR will be, let's say there are two inputs, it will give us A B bar plus A bar B, right? So this is the expression for two input XOR gate. Right? Now if this thing we want to realize with the help of gate, and this thing if we draw in the truth table, so let's see the combination in the truth table I am drawing here. So if there are two inputs, there will be 4 possible combinations in the truth table, right? So I am taking it like this is A, this is B, and this is XOR Y. So this Y is given here, right? This Y I am talking about. So here the combination will be 0 0 1 1 0 1 0 1, and the Y in that case, because it is XOR, so if both the inputs are same, it will give us 0. If there is a difference, then it will give us 1. This will be 1 and this is also 0. So that we already aware about. Now what we need to do is we write this expression like, so how do we write it? We write it like, this is A bar B bar, let's say. So I write it A bar B bar dot, let's say 0, this thing, right? The next thing I can write A bar B dot 1. Similarly, next row can be represented as AB bar dot 1. Similarly, the last row can be represented as AB dot 0, right? Now there are two variables and those are changing, so it is very easy to compare. If there are two variables, those are having four possible combinations. In XOR, if I talk about, not XOR, in MUX, if I talk about what are the variables which we will get in complemented way, these are just the select lines, right? Because inputs are not complemented. So AB combination, it is very easy to understand that A and B need to be equated with select lines. I hope you are getting it. So, and because there are two select line, we need to equate A with, let's say, S1 and B with, let's say, S0. We have to use, so I'm writing, we have to use, we can realize it 4 cross 1 MUX. So we can use 4 cross 1 MUX. In case we are using it, let's see it. So what is the Boolean expression of 4 cross 1 MUX? We know that. So the expression, let's say, y of 4 cross 1 MUX, we can say S1 bar S0 bar I0 plus S1 bar S0 I1 plus S1 S0 bar I2 plus S1 S0 I3, right? Now this expression which we are getting for this XOR, this thing we need to compare. So let's start comparison. Here we are comparing S1 with A. So this is being compared with A, and S0 we are comparing with B. So let's say this S0 is comparing with B. Now it is obvious that I0 need to have 0, right? Similarly, here we can compare. So S1 and S0 we have already set AB. Now I0 is 0. I1 we can compare here with this combination. So I1 need to be 1. Now in this combination here, this is already there. I2 need to be 1. And in this, we compare this thing. So I3 need to be 0. Right? So if you are able to understand this, now you can easily draw the circuit for that. So let's say I draw the circuit for 4 cross 1 MUX. So let's say here I'm drawing it. Let's say this is a 4 cross 1 MUX. So there are 4 inputs, I0, I1, I2, I3. There are 2 select lines, S0, S1, and there is output line. Enable line I am not mentioning because we are assuming that the circuit is enabled. So it is 4 cross 1 multiplexer. In short, we consider it MUX. Okay. So here it is Y. This is I0. Now instead of I0, because we are just realizing the circuit, so this is S0 and this is S1, right? This is input 0, this is 1, this is 2, this is 3. Now with this, let's start connecting the things. So how we will connect? This S0 is equating with B, so I am passing B here, and S1 as A, right? So this is fine. Now I0 is 0. so we need to pass 0 here. I1 need to be 1, so we need to pass 1 here. I2 need to be 1, so we need to pass 1 here, and I3 need to be 0. So this MUX will generate XOR, right? Now you can compare with any other function, any given function, right? I hope you are getting it. So let's say if you want to draw the circuit, or you want to implement, let's say, XNOR. So do the same thing quickly. So the function for XNOR, we want to realize XNOR or implement XNOR, the Y will be given like AB plus AB bar, A bar B bar, right? So this is XNOR. Now if we draw the truth table, the truth table will look like this, and quickly you can draw the circuit with the help of multiplexer. Okay, so the combination will be 0 0 1 1 0 1 0 1, and here it is Y. So this, when the same input will come in XNOR, it will give you value high. In case different inputs, it will give you 0 0, and this is a high, right? Okay, now if this is the scenario, you can write the expression here. So what you will get as Y here, you will get A bar B bar dot 1 plus A bar B dot 0 plus A B bar, this thing I'm saying, A B bar dot 0, and the fourth row is representing A B dot 1, because this is high here. So this is the thing. Now because we want to realize it or implement it with the help of 4 cross 1 MUX, so let me write the expression of 4 cross 1 MUX. So I'm writing the output of 4 cross 1 MUX, the output, that is, we consider, let's say, this Y. So this Y will have, if there are 2 select lines and there are 4 input lines, so this is select line 0, this is 1, input 0 1 2 3, right? So this Y will give us S1 S0 both complement I0 plus S1 complement S0 I1 plus S1 S0 complement I2 plus S1 S0 I3, right? Now we need to compare these two. So it is very easy to compare. Now S1 need to be compared with A. So I'm saying S1 must be equal to A and S0 must be equal to B. So S1 is being compared with A, S0 is being compared with B. I1, or you can say I0, need to be 1. Similarly, if you compare I1, I1 need to be 0. So I1 should be 0. Similarly, I2 need to be 0. So I2 need to be 0. And similarly, I3 need to be I3 we set as 1. Now here we will give, because this is S1, this is S0, so S1 we will pass A here, B here, and I0 is 1, so this is high. I2, I1 is 0, I2 is 0, I3 is also 1. So this MUX will behave like XNOR. I hope this is clear. So with this I am ending this lecture. Thank you.